exam ready, achieve top grades. Welcome to today's lesson. It is on Surds, part 1. So we are going to be simplifying, expanding, and rationalizing Surds. What you will master in today's lesson. Firstly, we're going to simplify Surds. What does that mean? We're going to break Surds into their simplest form and combine like Surds by collecting terms. In the second part of the session, we're going to be expanding brackets containing Surds. So here, we're going to be multiplying out single and double brackets, including squaring binomial surds. Thirdly, we're going to be rationalizing the denominator. So that will require us to remove surds from denominators, including using the conjugate for two-term denominators. What is a surd? It is the square root of a non-perfect square number. It ends up with a non-terminating decimal number. This is what we call an irrational number. Now let's consider the square root of numbers 1 to 10. Here we go. Now of those square roots, some of them will give us whole numbers. And these are the ones from the square root of perfect square numbers. 1, 4, and 9 in our case. So these give us whole numbers, that is, integers. Next, let's look at the square root of non-perfect square numbers. As you can see, they give us decimal numbers, and they are non-terminating decimal numbers. So those square roots that give us non-terminating decimal numbers are known as surds. Root 2, root 3, root 5, root 6, root 7, root 8, and root 10 in our list of 10 numbers. Why do the surds matter? Now, surds give us an exact value, as opposed to decimals, which are only ever an approximation in those cases. The next thing is that exam questions expect answers left in surd form unless you're told otherwise. Now, higher tier papers require simplifying, expanding, and rationalizing of surds in multi-step problems. You're going to be learning about 4 key rules today. The first one is the multiplication of surds. Square root of A multiplied by the square root of B gives us the square root of AB. Now, we can look at an example here. If you have the square root of 2, you multiply it by the square root of 3, you will end up with square root of 2 times 3. And this gives us the square root of 6. Over to the next rule. The next one says square root of A divided by square root of B gives us the square root of A divided by B. As an example, if you have got square root of 10, you're going to divide it by the square root of 2. This is equal to, now it's easier to write it that way, 10 divided by 2, and that ends up with square root of 5. That brings us to rule number 3. In this case, we are multiplying a square root by itself. So square root of A multiplied by the square root of A gives us A. Let's look at an example. If you take the square root of 5, you multiply this with the square root of 5, you end up with simply 5. I'll give you another example here. If you take the square root of half, you multiply this with the square root of half. Guess what? You get half. And the last one, that rule is about addition and subtraction of surds. Now, the surds have got to be the same surd. If you're having 2 root 5 plus 3 root 5, so it's just like collecting like terms. So we're going to get 2 plus 3 which is 5 root 5. That's an addition. In case of a subtraction, let's say you got 10 root 3 minus 4 root 3. That would give us 6 root 3. In section A, we are simplifying surds. Now, to make things easy, I've put this list of square numbers in increasing order. Now, we're going to be using this when we're going to be doing the simplification of surds. Now, in this case, we got to take the square root of 180. Now, the square root of 180 requires us to split it into factors, 2 factors. So we got 1 and 180. We got 2 and 90. We got 3 and 60. We got 4 and 45. So you will notice at this point that we got 4 is a square number, but we're going to go past it as it is not in the biggest square number for as a factor for 180. We keep going. Okay, so the next one is going to be 5 times 36. Now this takes us to the biggest square number, which is a factor of 180. Therefore, if you take the square root of 180, you can split this as 36 multiplied by 5. Now, this will remind you of the product rule that you can see right at the bottom here. Okay, but we are using this in reverse. Now, the square root of 36 is going to give me 6. That one, we don't have an exact number, a whole number, so we're going to leave it in surd form. So that would be square root of 5. And that, therefore, is our answer. Now, let's look at the second example. We got 50. Again, we're going to have to split 50 in 2 factors, 1 and 50, 2 and 25. Here we go. Now, the second column is the one that we're going to be looking for. So this is 25. This is our square number that we're going to use for 50. How about 18? So let's look at 18. Factors are 1 and 18, 2 and 9. Now we got our biggest square number, which is 9. So how are we going to write out the answer? Now, square root of 50 times the square root of 18 will be written as square root of, now we're going to take the bigger number first. So 25 times 2. And then we're going to multiply this with the square root of, now remember 18 is going to give us 2 and 9. Therefore, I'm going to write 9 and 2. Square root of 25 is going to give me 5. 2, we can't get a whole number, therefore we leave it in surd form. And then you're going to multiply this as the square root of 9, that gives us 3, multiplied by root 2. Now, you will normally multiply 5 and 3, we can get 15. Now, the next thing is you're going to multiply root 2 by root 2. That reminds us of another rule, which is the squaring rule. Square root of a times square root of a gives us a. Therefore, square root of 2 multiplied by the square root of 2 will give us 2. Therefore, we're going to write it times 2. Now, I could have written times 2, or you can put it as brackets. It's the same idea. And the answer is 30. The next one is going to give us square root of 12. Now, let's look for the factors of 12 with a bigger square number. So 12 is 1 and 12, 2 and 6, 3 and 4. So in the second column, That's where we're going to be getting our biggest square number. Okay, so that is 3 times 4. So we're going to get 4 square root of 12 is going to give me, now remember, I'm going to take the bigger number first, makes it easier. Now we're going to work out 27, which is 1 and 27. You can't do 2, you're going to go for 3 and 9. So 9 is the square number here, okay, the bigger square number. So we're going to write 3 multiplied by 27 is split as 9 and 3, and square root of 48. So 48, I'm going to write 48 here, 1 and 48, 2 and 24, 3 and 16. And here's our biggest square number, 16. So the square root of 48 will give me square root of 16 multiplied by 3. Now, if we must simplify further, the first line, square root of 4, that gives me 2, so I'll put brackets there, and then that one will result in a surd. The next one will give me 3, 9, square root of 9 is going to give me 3, square root of 3 will remain as square root of 3, unchanged, and that will give me 4 root 3. And don't forget the equal sign. So in that case, we're going to be multiplying 4 and 2, 4 root 3, plus 3 times 3, which is 9 root 3, and then take away 4 root 3. Now, let's refer to this rule where you are adding terms which are similar. Why similar? Because you got root 3 in all of them, which is a common term or common factor, but then we got to combine the others. So 8 will be added to 9, and then you're going to take away 4. 8 plus 9 is 17. 17 take away 4, that is 13. So 13 root 3 is the answer. Now I'm going to let you practice on the next, on the other side of that slide. So here we go. You practice them and I'll give you the answers shortly. So see you on the next slide. So how did it go? Hopefully it went well. Okay, now we're going to look at section B. In this case, we're going to be expanding brackets with surds. Let us see how that works. So in our first example, we are multiplying root 3 with brackets. So we're going to do the multiplication term by term. So root 3 times root 12. So let's start writing this out. Root 3 multiplied by root 12 plus 5. So root 3 times root 12, that gives you root 36. And that's the product rule. And then we're going to have root 3 times 5, that gives you 5 root 3. Now you will notice that you can simplify root 36 to 6, and then you get 5 root 3, and that gives us the answer. That was multiplication with single brackets. Now we're going to have multiplication with double brackets. Now I'm going to multiply 2 and 3 straight away. So 2 times 3 is going to give me 6, and then multiply 2 and root 5, and be careful of that negative number. So negative 2 root 5. Next, I'm going to multiply the second term with root 5 and root 3 multiply together. So that gives me 3 root 5. and then root 5 times root 5. Now you can see this is an identical surd multiplied by itself, okay? Therefore, it ends up with 5. And again, be careful of that negative sign. So positive multiplied by negative gives you a negative. So that's going to be negative 5, okay? And then the next line is going to be, we're going to combine like terms. So 6 minus 5, that's going to be 1. And minus 2 plus 3, minus 2 plus 3 gives you 1. We're not going to add the 1. We're going to, because it becomes invisible. Some people would say plus 1 root 5, but we will just write root 5, which is a neater way of writing the answer. Next example is when you're squaring brackets. So here is how it works. So we're going to get root 7 plus root 2 multiplied by itself. Root 7 plus root 2 bracket, close brackets. We're going to multiply root 7 and root 7 together and identical surds, so that gives you just a number. Root 7 multiplied by root 2. Now this is the product rule, which we have as the first rule down here. So that's going to be plus, so root 7 times root 2 gives you root 14. Next one is going to be root 2 times root 7. So that's going to be root 14 again. And then you're going to have root 2 multiplied by root 2, identical surds, which ends up with just a number. Now, what we're going to work with is combining like terms. So the 7 and the 2 will be combined together. So 7 plus 2 is 9. And then we're going to combine these two surds. Okay, so this is the addition rule, which gives us therefore. So remember, that is a 1 here, there's a 1 here, that's 1 plus 1, that gives you 2 root 14. And here is your answer. So I will let you practice on the next one, which is the calculation side. It's for you to practice. Okay, you can pause the video here, you practice answering those questions, and then you can compare your answers on the next slide. See you on the next slide. Okay, hope you've done well here. Let's move on. In section C, we're going to be rationalizing the denominator. And we're going to be looking at the squaring quite a bit. Okay, let us see how that works. So rationalization. Okay, just to remind you that square root of a multiplied by the square root of a is equal to a. One word about conjugate surds. So what does that actually mean? Conjugate. So if I have 2 plus root 3, its conjugate is just going to be 2 minus root 3. Or if you have 4 minus root 5, the conjugate of that is going to be 4 plus root 5. So you will notice what I've done is I just swapped the positive for the negative and the negative for the positive. So hopefully you have understood the idea of conjugate. All right, okay, so let us see why we're using conjugate. The reason for conjugate is we can apply this rule. So a plus b multiplied by a minus b gives you a squared minus b squared. And you may recall that this is called the difference of two squares. Okay, so this is for your further reference. in shortly. Difference of two squares. Okay, so these are the things that you need to make note of. You need to be remember before we actually embrace this part of this topic. All right, so let's get on with this. First of all, we got 5 over root 3. Now, this is the easiest of all three questions. So 5 over root 3. How do we remove this surd? We simply multiply the surd by itself. But the way we're going to do it is as follows. So we're going to multiply by itself here. However, we cannot change the value, so we're going to keep the value the same. So root 3 over the root 3. In fact, that means just 1. Root 3 over root 3 is 1. However, we're going to change the form of that. So what is happening here? So 5 times root 3, you're going to get 5 root 3. Underneath the numerator, rather the denominator, root 3 times root 3 becomes 3. So what we've achieved here is that we've got the surd as in the numerator part, but not in the denominator. Let's move on to the next one. And this is where we're going to be looking at conjugates. Okay, so conjugate. So conjugate is written like so. Okay, so let's get started. 4 over 2 root 3. In a similar way, we're going to multiply by a number. The numerator and the denominator are going to be identical. However, over here, we're going to be writing the conjugate of 2 plus root 3. And this is going to be written as 2. Remember, we swap the sign, minus root 3. And numerator will be just identical to the denominator. Let's dress that up with brackets. And now let's do the multiplication. So 4 times 2, which is 8. 4 times negative root 3, which is negative 4 root 3. And if you remember, we talked about the difference of two squares. What does that mean? So a plus b multiplied by a minus b ends up with the square of the first term minus the square of the second term. So the square of the first term is 2 squared minus the square of the second term, which is root 3 squared. And I'm going to carry on that side. So I'm going to write 8 take away 4 root 3 divided by 4 minus 3, which gives us 1, and that means this is 1, and therefore that is 1, and therefore the answer is just simply 8 minus 4 root 3. Here we go, that's the answer. The third part, let us see how it works. So root 5 plus 1 as the numerator, and the denominator is root 5 minus 1. Now, if you remember, we got to work out the conjugate of the term, which is the denominator. So let's work this out. So here, what's the conjugate of that? Is the square root of 5 plus 1. Okay, so this is the conjugate. And therefore, we copy the denominator and as for the numerator. So root 5 plus 1. So we're going to multiply these two together, top times top, or numerator times numerator. Okay, so let's start with the multiplication, expand the brackets. So root 5 times root 5, this is, remember, the squaring of surds. So square root times square root cancel out, so we end up with a 5. Then root 5 times 1, so that's 1 root 5, or simply we just say root 5. And now we're going to multiply the next one, which is 1 times root 5, which therefore becomes root 5. 1 times 1, so that becomes 1. Okay, all terms are positive. Let's look at the bottom part now. Okay, so the first multiplication is root 5 times root 5, and that gives me simply 5. Root 5 times 1 plus root 5. Okay, and the next multiplication is going to be negative 1 times root 5, negative root 5. Therefore, we will go to write root 5. And the term that we are missing out is simply, that was the second one, root 5. Okay, and and finally, the last terms that are multiplied together, minus 1 times plus 1, which gives us minus 1. Okay, and we could have done that using the difference of two squares, okay, as well. Now, let's combine these terms. So 5 plus 1 is 6. 6 plus, you got root 5 plus root 5, that gives you 2 root 5. And then divided by, what's 5 take away 1, which is 4. And these cancel out. And so you can say that this is the answer. Okay, or you can factorize here. So 2 multiplied by 3 plus root 5. And then you got 4 over here. So 2 and 4 have got 2 in common. So 2 into 1, 2 into 4, 2. So the simplest form of this answer is going to be 3 plus root 5 over 2. Now you can practice on the second part, on the second half of that slide, and I will reveal the question now. Here we go, and let's see if you can get the answers right. I'll see you on the next slide, hopefully with your answers correct. Here we go, and that ends our section C. So moving on, let's recap on today's session. So we've looked at 3 different skills. You should by now be able to simplify surds by finding the largest square factor. You can also expand now, brackets carefully, and then collect like surds. And finally, what you've achieved is you've been able to rationalize denominators using the conjugate for 2-term denominators. What we've got on the next video are surd equations, harder rationalizing with algebraic surds, and exam-style problem-solving questions. Until then, it's goodbye for me.